Hi guys, we are in our final example for lesson 16 where we're doing double integrals. And so this question is asking us to find the volume of the solid line under the elliptical paraboloid of x squared over 4 plus y squared over 9 plus z equals 1 and above the region of -1 to 1 and then -2 to 2. So first of all, over here, let's just discuss that this is telling us that x is in between -1 and 1. So those will be our bounds for our integration for x. And that y is going to be in between -2 and 2. So there's our first part. The other thing we're going to rewrite over here is we want to get it in terms of z. So z is going to be a function. And I said this in the previous video, that z is going to be a function with respect to x and y. So I'm going to rewrite this z as x squared 1 minus, actually, let's erase this, 1 minus x squared over 4, and then minus y squared over 9. And so we have exactly all that we need to solve the problem. And so I'm going to go ahead and start writing out the integration of. And so again, doesn't matter if we start with x or start with y. I'm going to go ahead and start with x. So I'm going to leave my y's on the outside. I'm going to integrate from -1 to 1. I'm going to go ahead and write down my z function of 1 minus x squared over 4 minus y squared over 9 dx dy. Again, it does not matter the order. Again, the reason why I'm choosing this is because I like ones better than two. So I'm going to start with a number that's smaller and do it this way. So with that being said, we're going to go ahead and do -2 to 2, and we're going to integrate this, remember, with respect to x. So 1 obviously is a constant, so we're going to integrate x1 as x. And then we have our 1/4, and we're going to integrate x squared as x cubed all over 3. And then minus, so guys, remember this entire thing here, -y squared over 9 is a constant, right? We're doing it with respect to x, so it's going to be a constant. So we're going to integrate this as just y squared over 9x. And we're going to evaluate this whole thing from -1 to 1 of dy. So this will get a little bit messy. So we're going to go ahead and do our best to keep this as clean as possible. So we're going to go ahead and write down our function as, actually, I'm going to start it over here because this is actually pretty long. So let me erase all of this and go over here. So I'm plugging 1. And then when I plug in 1 here, I get 1/4 times, -1/4 times 1/3, which is -1/12. And then I'm left with -1 or -9 y squared. Remember, we're just replacing the 1 everywhere we see an x and not where we see a y. So this whole thing is going to be constructed. Now we're going to do the same thing with the -1. So we're going to get a -1. We have -1 cubed, right, which is me again negative. So we're going to do a plus 1/12 because -1/4 times -1/3 is positive 1/12, and we get a positive 1/9 y squared dy. So when we clean this up, right, when we clean this up, and trust me here, it's a gross problem to do, but once we clean it up, we are left with 11 over 6, when we do all that nice little math, minus 2/9 y squared. And we're finally at that point where we can just enjoy the fact that this is a really easy function to integrate. All right, so we're going to look at this problem. So we're in the home stretch now. We get 11 6y minus 2 over 9 y cubed over 3. Evaluate it from -2 to 2. And trust me, friends, that this becomes pretty nasty. You know the fundamental theorem of calculus part 1. You plug in the 2 to both these things, plug in the -2. When all is said and done, all right, when all is said and done, you will get an answer of 100, and that is a really bad 6. So let me fix that right now. You'll get 166 over the number 27. So I think, obviously, this problem is not the nicest thing to assess on. It's just a nice thing to talk about. So there you go. There's your problem. I hope this makes sense. We're officially done now with lesson number 16. So I will see you guys again in our next video. So take care.